Okay, good evening, everyone. Can you hear me?
Yes, sir.
Okay. And then let me know, can you see the presentation that I shared with you?
Yes, sir. We can hear.
Okay. Okay. Got a little bit late because of bad weather conditions. I think that you can also hear the thundering. So no matter, let's continue because this is the rest of the op-amp part from our last lecture. Uh, and let me know, can you see what I'm writing here? Can you see it?
Yes, sir. We can
So,
see.
then I will give a little recall from the last lecture. And there we discussed about the operation of PAMs, and we identified what is enough PAM. Then after that, we discuss about the difference between the ideal and a real op amp. And then we learned about the op-amp golden rule. There are second and third rule that we discussed, and in those rules we oftenly use in our calculations. So therefore, that we want to know that the current, there is no any current flows into the op-amp, as well as when there is a negative feedback, the voltage at these two terminals are equal. And by using that, that we discuss about the virtual earth. And after that, we discuss about the inverting amplifier, and we got the equation for the gain, and then the non-inverting amplifier. And after that, we discuss about the comparator and the application of a comparator, then the voltage buffer. So today we are going to discuss about the differential amplifier. And for this one also, we want to know about, we have to use the op-amp golden rules. So normally in differential amplifier, this is the sum of those two inverting amplifier and the non-inverting amplifier. Oh. So before moving to that part, please tell me what is the gain of a inverting amplifier? Inverting amplifier gain what? You have to give answers. Inverting amplifier gain what? No. Can't you hear me? Another. Mana country kan cover එකන කුත්තා දෙන්නු. We can කිසිම කෙනෙක්ට inverting amplifier එක ගැන
minus R2 divide on R1.
yeah. So the gain is minus R2 divided by R1. And what is the amplifier of the what is the gain of the non-inverting amplifier? Okay, I will call you by your names. Randomly. So, Enuka Sangeet. So, tell me, what is the gain of the non-inverting amplifier? Enuka, you have to unmute your microphone and give the answers. Okay, then any volunteer?
R divide R1.
Yes. So it's very easy to understand. 1 plus R2 over R1. Here in both cases that you can see R2 over R1. Inverting amplifier it is minus. And non-inverting amplifier it is 1 plus. And here in the differential amplifier, the final we get R2 over R1 in V2 minus V1. Okay. Then let's move on to the differential amplifier. As I told you, it is the composition of these two inverting amplifier and the non-inverting amplifier. So therefore, we use the the 2 and 3 golden rules to prove this equation. So therefore, in the first one, in the second golden rule that we discuss is no any current flow into this op amp. So therefore, what's happened in differential amplifier? I think you can see this configuration of the amplifier, and therefore the V1 flows through this resistor R1. Then no any current flows towards the op amp, so therefore it flows through the resistor R2 and to the V out. And then in this part, you can see the two resistors are connected. So therefore here a current flow, not similar to this one, the current is here is I2, but a different current I1 is flows through this, but it do not go towards the op amp. So therefore it goes to R3 and after that flows to the earth through R1 through R4. So then we can obtain the two equations. The first one, you can see this can be obtained by keeping V equal IR and by that we can take I equal V over R, delta V over R. So therefore, when we apply this to the R1 resistor, you get this. Sorry, here the I1 and I2 given. I1 is here and the I2. So let's take I3 and I4 like this, I3 and I4. And you know I3 and I4 are same, as well as I1 and I2 are also same. Those are equal. So then, here you can see V1, when we keep I equal delta V over R, so we get through this resistor V1, current flows from V1 to V minus. So V1 to V minus over R1. And it is equal to the current through this R2 resistor. So therefore, this one is when we apply the V equal IR to the R1 resistor. And this is what we get when we apply the I equal delta V over R to the R2 resistor. So you can see here the resistance is V minus and the current flows from V minus towards the V out. So V minus towards V out over R2. And then you get this equation. Then you have two equations. And now we want to discuss about this branch, V2. That means non-inverting input. So therefore, the non-inverting input, you can see, actually we can use the voltage divider method easily. But for your convenience, I use this I over delta P over R equation. So therefore, let's use it for R3 and R4. To R3, that we get the equation V2 minus V plus is over R3, and it is equal to the voltage V plus minus 0 over R4. It's using the I equal delta V over R to these R3 and R4 resistors. So therefore, by this you can obtain R4 into V2 minus R4 V plus is equal to R3 V plus. So there you can subject V plus. So here you get R4 V2 is equal to R4 plus R3 V plus. So therefore, by that you get this equation, the second one. So now we have these two equations, and by that means subjecting the V out from this equation, and you have to apply the V plus, it's equal to V minus, and by that you can obtain the final equation. Okay, try to get the final equation from the two equations that we got here. මෙතන ගත්ත equations දෙකෙන් මේකෙන මෙන්න මේ equation එක ගන්න try කරන්න. So if any one of you do not understand or have any confusion regarding this, please raise your hand. මේක මොකක් හරි ප්‍රශ්නයක් තියෙනවා ඔයාගේ මේ hand raise කරන්න. අතට මම කතා කරනවා. හරි. Okay, did you get that answer? Okay, you have tried these things because these proving parts that you have to prove this the gaining equation of amplifiers in your exam also. So therefore, you should be aware of these things. And I will show how you can get the answer. So therefore, now you know V plus C is equal to V minus. Here this is the first equation, second one, and third one. This is of the golden rule. And from the first equation, you can subject V out. So you will get V out as let's take this one as subjects. That mean V1 R2 minus R2 V minus over R1 to R1 and then actually it's easy to get the minus of this one, minus and plus, and then plus V minus over R2. So this is the V out. So in this part, that we know V plus is equal to V minus. And then you can get V out is equal to minus R2 over R1. V1 plus R2 over R1 plus 1 over R2 into V minus. So now you know by the third equation, V minus is equal to V plus. So therefore, then there's not enough space to do the calculations. Then you have to substitute this V naught from V plus we got here. Then you can try. You will get the equation that's shown in the presentation. So actually you do not need to remember this equation, but you would remember the equation of the inverting amplifier and the non-inverting amplifier. But this equation, if you get any question from these amplifiers, that the first thing that you have to prove this equation. At first, you have to prove this equation. After that, you have to do the calculation part. So, okay. So, this is the equation that you got. And you can see normally that we are given the equations as, we are given the differential amplifiers as R3 is equal to R1 and R4 is equal to R2. So actually there can be differential amplifiers with R1, R2, R3 and 4, R4, four distinct with four distinct resistance. But here normally that we use the differential amplifier to get the amplified difference of V1 and V2 terminals. That means that voltage are non-inverting and inverting inputs. So what I say, the difference between the voltages in one non-inverting input and the inverting input, then after that it is multiplied by the value R2 or R1. This only happens when R1 is equal to R3 and R2 is equal to R4. Okay. So you can note down what you need and you have to prove this. And this is just easily because this V plus is equal to V minus. So just keep it here. And now think, if we have V out is equal to this equation R4, R3, R1 and R2. But as we are taking R1 is equal to R3 and R2 equal to R4, so therefore that we can substitute these values. This R4 with R2, this R3 and R4 with R1 and R2. And then the top part R1, R2 over R1 and V2 minus R2, R1 over V1. So you can cancel this R1 plus R2, then you get this equation. So this is how you can obtain the gaining equation of the differential amplifier. So note down the important things that you need. Okay, now this is the differential equation. So differential amplifier. And in the amplifier, you can see the R1, the R3 and R4 replace with R1 and R2 actually. This means the R3 equal R1 and R4 equal R2. Okay. Now this is the equation that you should remember. It just easy to remember. You know that in the all amplifiers that we are using R2 or R1. That means the feedback resistor or input resistor. That means the resistance of R2 over the resistance of R1, and it is multiplied by the voltage difference between these two terminals, V1 and V2. Okay. Now you have a small problem, then try it. And after you obtaining the answer, please keep it in the chat box. And also, if you have any confusion, you can raise your hand.
Recording in progress.
Yes, I see that uh, all of you get the answers correct. Where our equation is, we get V out as R F over R in. That means input resistor and output resistor. So okay, I'll use the terms that given here. So therefore, it is R1 over R2 over R1 in to the difference of the voltages. And you must know the V2 is the voltage at non-inverting input. And here is the voltage at inverting input. So the answer that you get V out as R2 is equal to 10 kilo ohm over 1 kilo ohm into 0.2 volt minus 0.8. So therefore the voltage is minus 6 volt. So raise your hand if you get this answer. Okay, actually, this is easy to understand. If you could not, please note down these things and I will share the presentation with you. Then you can refer it for more details. Okay. Then let's move on to the next amplifier. And it is a differentiator. So what is differentiator? So I think you know about the differentiation. That in your 1-1 maths you have learned about the differentiation. So therefore in differentiation what we do, we get the rate of change of any parameter or any variable. So before moving into the into the differentiator, so tell me, do you know any equation relating to the capacitor? That means the capacitance of the capacitor, then the charges inside the capacitor, and the voltage at the two ends of the capacitor. So tell me, do you know any equation? Have you heard about the equation Q equals CV? Q equals CV के लिए कहा थी ना?
Yes, sir.
Yes. That's we are using in your O levels related to capacitor. But in advanced level, so and after that in our university level, that we are going to discuss about the rate of the change of the charges. So actually, if a charge positive or negative is flows, then you can find out a current. So therefore, that we can get dq over dt, that means the change of the charges versus the current, so versus time. That means the rate of the change of the charges is equal to c. C is the constant. The constant can be so okay. I take the whole part dv over dcv over dt. So that means I applied this dt to both sides. So therefore, what you get? dq over dt is equal to c into dv over dt. In this part, you get the rate of the change in rate of the charge means the current flowing of the current in any time. It's equal to c dv over dt. So therefore, we get the equation for a capacitor with the capacitance C, and the current flows through that capacitor is equal to I1. So here you can see I is equal to C dVC. VC means what? The voltage at the two end of this capacitor over dt. So okay. Now tell me what is the voltage at this end. So before that one, tell me what is the voltage here. මෙතන voltage එක කීයද? මට answers දෙන්න chat box එකේ. Yes, it's 0. And the voltage here? It's also 0 volt. So therefore, what is now the voltage in this end is V in. So the voltage at the two end of this capacitor is 0 and V in. That means the voltage difference is V in. So that's why here you get VC is equal to V. And here by the first equation, that means keeping this I equals C into dV C over dt, and by that equation we have obtained the left hand side, and the right hand side you can obtain using V equal IR to the resistor R. So therefore, the voltage here is V out, you can see, and this voltage is 0 because it is directly connected to this minus negative terminal. So therefore the voltage here, as the current flows in this direction, 0 minus V out is equal to I2 plus I2 into R. So the current I2 is equal to minus V out over R. So you get this part from the right hand side from this V equal IR equation. So now you know the current I1 flows through to this junction and turns here because no any current flows towards the op amp. And after that, that I1 current is equal to I2 and flows through this resistor. So therefore that you can get I1 is equal to I2. So I1, here you get the current to the capacitor, and I2, you get the current through the resistor. So therefore that you can simplify this equation and get a relationship between V out and V in. So therefore, if you connect a capacitance, if you connect a capacitor, instead of the input resistor, so you get the differentiator. So the differentiator that we can get this V out. How you get V out? V out is equal to minus RC into dVin over dt. Okay, so you can note down the things, the important facts, and during that, you can ask any confusions for if you have any hesitation, you can ask. Actually, these are very easy to remember that you can see. You won't only want to remember the circuit of the inverting amplifier. So you can obtain a differentiator by replace the input resistance with a capacitor. Okay, I think you all have an understand with this part. then you want to obtain the equation for the integrator. So this equation, there should be a integral sign. So the equation should be like this, and you can see this is the integrator also similar to the inverting amplifier. In that case, in the differentiator, that you have to replace the input resistance with the capacitor, but in the integrator, that you have to replace the feedback resistor with a capacitor. So therefore, now what you have to do is keep I equal C dV over dt equation to this capacitor, and use the V equal IR equation to this resistor, and there are two currents. So this I1 and I2 are same because there is no any current flows towards this op amp, and you can find out the voltages and obtain this equation. So try this. So now we have to write the two equation for this and obtain this equation. So do it within 5 minutes. Okay, and if you obtain this equation, and let's see for the I2 that you have to keep only dv over dt. I2 is equal to C into dv over dt. And the voltage difference beside these two parties here, you can see the voltage is grounded, so 0 volt. Therefore, by the golden rule, with the negative feedback, here 0 voltage. So therefore, you can see the voltage is 0 and here V out. So the voltage difference is I2 is equal to C into 0 minus V out. And this is the first equation. And the second one is you can obtain with IR, V equal IR. So therefore, I1 is equal to V in minus 0 over R. So did you obtain these two equations? So raise your hand if you obtain these two equations. Raise your hand if you get the second equation. දෙවෙනි එකක් ගත්ත කට්ටියද? Okay. So proving this part is up to you because you have done the integration and differentiation in your first year. And as well as you do not keep any interaction. I cannot do anything regarding this one. So these are the two equations that you can obtain. And then in this part, here you can see how you can get this equation. And as I told you, you have to keep the integral sign in this part. So therefore, I show how to get this equation. And then I1 is obtained like this. So therefore, you can equal this, sorry, equal this I1 and I2 current. Then you can obtain this equation and by integrating this one. So you know the integration part. So keeping the integration d v out over dt and equal integration v in over rc, and this integration should be done by dt. So therefore, the to the integral, this derivative will be cancelled. So therefore, finally, the V out is equal to, here you have to keep the minus sign, minus 1 over RC integrate in integral VIN dt. So this is how you can obtain the equation of the integrator. Okay. So the next one is the inverting summer. So how you can get the equation for the inverting summer. That means the gain of that inverting summer. So before that, let's see why we are using an inverting summer. So inverting summer, we use it to add three different voltage values. That means we can add two voltage, two or three or many voltage values. How you can do it? So you have to get an operation amplifier, so you can see it. Then the non-inverting input is, you have to ground it. So the voltage here is 0 volt. And the voltage in the inverting input also will be 0 because there is a negative feedback. And then what you can gain, you can apply now you see there are three branches here. V1, V2 and V3. And here the V out. So you can get V out equal as V1 plus V2 plus V3. But as we are feeding these voltages to the inverting input, so all the sum will be inverted. So this is what we are getting as the output from this inverting summer. So now let's see. So this is the equation. And now let's see how we can prove this part. So now what you can see? There are three branches and the current flows in all the three branches. So there are three resistors and the current flows through these resistors and the current in this part is 0. Sorry, the voltage at voltage here is 0 and no any current flows into the op amp. So then what happened? This current I1 and I2 and I3 comes and it flows to this junction and all the currents flows through this feedback resistor. So you can see this IF is equal to I1, I2 and I3. The sum of I1, I2 and I3. So how we can get I values? So here the voltage is 0. So that therefore the voltage is 0 and as well as the voltage here also we have a 0 voltage. And in this part the voltage is V out and the every resistor in the left side of those resistors get 0 volt. And now you can apply, the equation V equal IR. So I equal delta V over R. So for the first one, for the RF, the current through the RF is IF. So IF can be obtained by V minus over RF. And the current in this branch, I1, I2 and I3, you can get. I1 is V1 minus 0 over R1. So now you can cancel 0. Therefore, V1 over R1. And here V2 over R1, the I2 current. And the I3 current is the V3 over R3. So therefore, the V out you can get by this equation. So what you have to do, keep this minus sign with RF and shift it to the right hand side. So therefore, you get an equation like this. V out is equal to minus RF into V1 over R1 plus V2 over R2 plus V3 over R3. So therefore, then let that you have to, when you are designing the inverting summer, that you want to get all the 4 resistors of similar values, similar resistors. So therefore, RF is equal to R1, R2, and R3. So therefore, you can cancel out this RF, R1, R2, and R3. So then you get the final answer, V out is equal to minus V1 plus V2 plus V3. So this is how you get the voltage out, then output voltage of this inverting sum. Okay. Actually, what you have to do is that you want to practice these things by proving 2 or 3 times. If not, you cannot do these proving parts. So you need a constant practice. Okay. I think and as this is easy one, so you can understand this inverting summer. And let's move to the next part. And actually, this is an exercise for you. And for this one, you can try. Actually, this is not any specified amplifier that we are using. So this is for to practice these things. And here you can see they are giving 2 voltage to the non-inverting input, sorry, inverting input, and there are 2 voltage through 2 input resistors toward the non-inverting input. And also there is a negative feedback is connected. So therefore, you can try this. And okay, then I will collect this part as your assignment. So therefore, that you have to do this. Okay, wait. So did you understand what we discussed today?
Yes, sir.
Yes. So let me know if you have any questions. මේකත් එක ප්‍රශ්න තියෙනවද මොනවාරි? So actually there are some complex, not complex, these are easy maths parts. So this is dealing with simple integration and differentiation. And also these all are related to the op-amp golden rules. So therefore you have to practice these things. මේ parts ටික හොඳට practice කරන්න. නැත්නම් ඉතින් නිකන් හිතෙන්නේ අමාරු part එකක් කියලා තමයි. එහෙම එකක් නැහැ. මේ ඒකින්ද මේ අනිවාර්යෙන් ඒකේ මේ ගණන් පාස් ටික කරන්න. So I think you can see the screen. මේ screen එක පේනව නේද? So can you see the shared screen? Not yet, no. පේන්නේ නැද්ද?
පේනවද සර්?
ඔව් හරි. So this is a assignment and you have to submit it when you are physically available in your in the campus. So then so Sankar, you can collect all the assignment sheets and give it to me. Okay.
Okay sir.
Okay. Then okay, this is a small remember. හරි. එහෙනම් මේ ටික කරන්න. තව පාඩයක් කියන්න දෙනවා මේක කරපු වැරද්දක්. හරි. ඔන්න දැන් මේ ඔයාලා යොක සිනොප්සිස් එකක් තමයි මේ තියෙන්නේ. දැන් මිනි ප්‍රොජෙක්ට් එක මේක අසල දෙනවනේ. එක සිනොප්සිස් එක තියෙනවා එකක නේද? අහුණා දැන් මේ කීප එක. දැන් මෙන්න මේ ඔබ්ජෙක්ටිව් මේ outcomes එක ලියලා තියෙනවා. Let me know if you would like to simplify it further. ඒකෙන්ද දැන් මේ හැමදාම කියනවා වගේ දැන් කිව්වනේ AI use කරාට ප්‍රශ්නයක් නැහැ. මේ AI use කරාට අනිවාර්යෙන් ඔයාලා මේ දෙන දේවල් කියවලා බලන්න ඕන. දැන් ඔහේ නිකන් ඔහේ සබ්මිට් කරලා තියෙනවා නේද? ඉතින් අපරාධ මේව සබ්මිට් කරන එකේ තේරුමකුත් නැහැ. මේ ඒකින්ද ඔය පාර්ට්ස් එක මතක් කරේ ඒකින්ද ඉස්සරහට දැන් now you know on your 25th of November you will have the final project evaluations. No, so have you finished your works with the mini projects? Mini projects වල වැටි ඉවරද? කරගෙන යනවා තින්නේ. ඒකින්ද ඒ පාස් කරන්න. ඒතකොට අනිවාර්යෙන් ඔයාලා වයිව සෙෂන් එකට එද්දි මම මොනවද වයිව එකේ සහ මේ මිනි ප්‍රොජෙක්ට්ස් වල අන්තිම ප්‍රොජෙක්ට්ස් එකේ අහුණු දෙන්නේ මොන ක්‍රයිටීරියාස් වලටද කියලා ඊමේල් එකේ මෙන්ෂන් කරලා තියෙනවා. ඒකෙන්ද ඒව ගැන චුට්ටක් බලලි කරලා අවධානයෙන් ඉන්න. හරි. So this is all for today. And okay, I think that you have no any question, but you have to do the continuous practice these things. And okay, thank you for joining the lecture and have a nice day. Okay, good night for all.
Thank you sir.